We're going to be talking about the rates of reactions, and the real question that we're trying to get at is what are some ways a reaction can be sped up? Because oftentimes chemical reactions are kind of slow, and we would like to speed them up. So, how do we do that? First of all, let's talk about what's in a chemical bond. So, there's always potential energy stored in the bonds of molecules. So, here's an example. So, octane, which is just gasoline, and this is just a very simple hydrocarbon. 8 carbons and 18 hydrogens. And this fossil fuel is easily combustible. However, on its own, it's generally in the liquid form. And what that means is, as it's a liquid form, when it's just sitting underneath the earth or waiting to be put in your car, all of the energy is stored within the bonds of the oil, which is considered to be potential energy. And so the problem is that that energy is locked into the bonds. Well, how do we get that energy out of the bonds and actually utilize it? The best way to do that is to release the energy through a combustion reaction and to break the bonds of every single one of these carbons and hydrogens. All those bonds need to be broken. The best way to do it is with combustion, so fire. So let's think about it in terms of a car. So your car has an engine, and the engine has cylinders in it where the fuel burns, and the fuel burns because the car has spark plugs, and the spark plugs are basically little sparks that ignite the fuel, and that whole process turns a crankshaft which powers the wheels to move you. But the whole process wouldn't happen if that fuel wasn't combusted, releasing that potential energy, turning it into kinetic energy. So you need some kind of spark to get the energy out of the bonds. Well, take that one step further, and scientists came up with what's called the collision theory. So the collision theory is just the time it takes for a reaction to happen. Again, most reactions happen very slowly, but we want them to happen faster. And so we figured out ways in which we can speed up the rate of a reaction. And a reaction is really going to occur on the molecular level between the collisions of the molecules. So two things have to happen on the molecular level. The colliding particles have to have enough kinetic energy and collide with each other. And not only do they have to have enough kinetic energy, they have to collide in the correct angle. So they have to hit each other just right in order to turn reactants into products. Because the end game is to release the energy of the reactants, they turn into products, and then we can then use that energy. There are four main factors that affect the rate of a reaction, which we can manipulate. The first one is temperature. So naturally, if you increase the temperature, the molecules are going to move faster, and if the molecules move faster, you're going to have more collisions, therefore a higher probability of reaction. Increasing the concentration, the more reacting particles you have, the more collisions you have. Again, it's just increasing the probability of having reactions occur. The particle size. You actually want a smaller particle size, and the reason why is if you have a million small particles, the surface area of that overall million small particles is larger than, say, if you just had one particle that was very large. So you want smaller particles because you have an overall more surface area, and more surface area means more reactions. Lastly, catalysts. Catalysts are really cool because they don't actually get used up in the reaction. They just help the reaction to proceed, but are left over at the end of the reaction, and they lower the activation energy required for the reaction to occur, therefore remove the obstacle or the boundary of the reaction.